Hello everybody, and greetings from the Delta College Planetarium. My name is Brian, and today I want to spend some time talking about observing planets in the night sky. Many people believe that you need a high-powered telescope to see the planets, and are surprised to learn that it is typically very easy to spot the planets in the night sky, and that they have, in fact, probably seen some of the planets many times without realizing. Hopefully, you have spent a few evenings outside during this summer to take a look at Comet Neowise, currently gracing our northern skies. If you take the time to look around the rest of the sky, and you're willing to wait up until the pre-dawn hours of the morning, right now you have the opportunity to see 5 planets with your own eyes. Only 5 planets are easily seen by eye in the night sky, and it is relatively rare that you can see all of them on the same night. We'll start shortly after sunset. Jupiter is one of the brightest objects in the sky. It has an apparent visual magnitude of about -3 right now, meaning it is far brighter than any star in the night sky. To the eye, Jupiter will appear as a bright point of white light in the evening sky. It will be one of the first objects you can see easily after the sun dips below the horizon. Jupiter will be in the southeast and will stay in the sky nearly all night. A small telescope or binoculars will begin to reveal Jupiter's secrets. A line of what appears to be faint stars will line up across the center of Jupiter. The number and positions will change, but over the course of a few days, you may identify up to 4 such dots in Jupiter's vicinity. These are Jupiter's 4 largest moons, sometimes called the Galilean moons, after their discoverer, Galileo. In order from furthest to closest, these are Callisto, Ganymede, Europa, and Io. Their relative motion around Jupiter can be detected over even just a few hours, and because these moons orbit Jupiter, occasionally they will be in front of, behind, or simply too close to Jupiter to make out, so you may not see every moon on any given night. If you have the ability to increase the magnification a little more, to say about 100 times or 150 times, a medium telescope will start to resolve details of Jupiter itself. Jupiter appears banded, striped in color. Red belts break up white zones in the planet's atmosphere. With good seeing, a sharp-eyed observer may see a red spot in the southern hemisphere of Jupiter. This is the Great Red Spot, an enormous storm. It's about twice the size of the entire Earth and has been observed for nearly 400 years. It takes Jupiter 10 hours to complete one rotation about its axis, compared to the 24 hours for the Earth. This means that in one day, Jupiter rotates about 2.5 times. So if you miss the Great Red Spot one night, you'll likely see it the next. To the left of Jupiter in the sky, lower and towards the east, there is another bright point of light. This one is considerably dimmer, with a magnitude of about 1. A few stars in the sky will be brighter, but this will still be one of the brighter objects in the sky and will be easy to spot, given its proximity to Jupiter. It will also stand out because of its color. It will look very yellow to the eye. Stars don't normally look yellow. They usually look white. Some might look kinda red or a little blue, but almost never yellow. That's a good sign that you're looking at the planet Saturn. Saturn is the most distant planet you can see in the sky with the naked eye. It's about 1 billion miles away, but where Saturn shines is in a small telescope. Reaching a magnification of about 50 times, even a small telescope will reveal a bright set of concentric rings encircling the planet. Saturn is my favorite planet to show people in telescopes because people who have never seen it before are blown away that it looks exactly like the pictures, and that inexpensive equipment will reveal it. Bumping up the magnification a little more, and you may start to see a faint point of light nearby the planet. This is Saturn's largest moon, Titan. Titan is the second largest moon in the solar system, only behind Jupiter's Ganymede, but it has something that Ganymede doesn't: an atmosphere. Titan is the only moon in the solar system to have one. Around 1 a.m. in the east, another bright point of colorful light will begin to rise. This one distinctly red. Very bright, about magnitude -1. It will be brighter than all but the very brightest stars and planets. This is the red planet, Mars. Mars is much closer to Earth than either Jupiter or Saturn, but it is also considerably smaller than those giants, smaller than even Earth. So seeing details on Mars is much more dependent on how close Mars is to Earth. Fortunately, Mars is currently nearing its closest point to Earth, which it will reach in October. This means right now is a good time to observe Mars. At around 50 times magnification, on a good night, you'll start to make out the pattern of light and dark areas that mark out the Martian surface. But you really want to be up at around 150 times magnification. At this power, you can resolve the surface in better detail, and have a chance of spotting the ice caps at the poles, and thin clouds in the Martian atmosphere. Around 4 a.m., a very bright point of light will begin rising in the east. At magnitude -4.5, the only things brighter in the sky are the sun and moon. This is the planet Venus. Venus is bright for a few reasons. Venus gets closer to Earth than any other planet. And Venus is pretty big, only slightly smaller than Earth. Venus is also wrapped in a thick blanket of clouds. These clouds reflect tons of sunlight off into space, making Venus appear so bright. Because Venus is so very bright, in a telescope you are unlikely to make out any detail on Venus. You will notice that Venus isn't round. In July, it will appear as a crescent in the telescope. Because Venus orbits the Sun nearer than Earth, we see portions of Venus that are not lit up by the Sun. So we see Venus change phases, much like the Moon does in the night sky. Just before sunrise at around 5:30, we can begin to spot the fifth and final naked eye planet, Mercury. Mercury orbits the Sun much closer than Earth and Venus, so Mercury never gets very far away from the Sun. Right now it's about as far away as it ever gets, about 20 degrees from the Sun in the sky. But because Mercury is small, it's not very bright. And being so close to the Sun, Mercury is always trapped in the light of dawn or dusk. Even at magnitude 0, it can be very hard to spot. Binoculars may help pick Mercury from the background light. Unfortunately, because Mercury is so small, a telescope will not be able to reveal much about its surface. It may reveal that, like Venus, Mercury exhibits phases, but not much else. To find it, trace a line from Venus to the brightest part of the horizon where the Sun is likely to emerge. And if you happen to see it, congratulate yourself for having spotted the most difficult naked eye planet. It's rare that the naked eye planets are all visible in the same night, so if you get the chance, spend a night outside or wake up early to see all of them. If you have a telescope, take it out to get a better view of the other worlds in our skies. This is Brian from the Delta College Planetarium, wishing you clear skies.